Christmas Eve. Let's go! Blizzard Basin. With everything replanted for next year, and with elephants and monkeys to tend the grove, you and the elves leave for the extraction point. Partway up the mountain that shields the grove is a flat, open area that serves as the extraction point. It's a bit of a climb, but nothing the expedition can't handle. At least, that would normally be true. Now that the mountain is covered in snow, things have become more difficult than the elves are used to. As the expedition reaches a valley that must be traversed to reach the extraction site, you find that strong, turbulent winds are pushing small blizzards of snow and sharp ice around the valley. It's a good thing everyone packed warm clothes. To make it across safely, you'll need to find a way to avoid them. Fortunately, it's easy to see all of this from the entrance to the valley. So you make a map of the valley and the blizzards, your puzzle input. So I'm just going to walk through today's answer. So the first thing we always do, of course, is bring our input. I just made a mutable list of Blizzard. A Blizzard is just a data class that has an X, Y, and a direction, and then directions just need them for the cardinal directions. And then for every line, for every character in each string, if it's one of the arrows, then we add that item into the list. So that's just to keep track of all the Blizzards that we have and where they are and everything. And so basically each one of these little guys is just going to get its own little thing, and we'll keep track of those coordinates. The next thing we need to do is I need the max X and max Y for the blizzards. The way I decided to do it is basically the max is going to be the last column it can be on or the last row it can be on. I'm not worrying about the rocks or anything. It also means you start with one on the other side. And then everything else is going to be in helper functions. So let's walk through those functions real quick. The first one is just to move the blizzards. We're going to go through each one in the list that was sent in and basically do its X and Y coordinates. And then depending on which direction it's supposed to go, increment or decrement one of those. If it hits zero, so if it hits this first column or this first row, then we of course move it to the max. And again, the max is already the last column and row it can be in. And if it hits the max, then we move it to 1. So easy enough on those. And then we update its coordinates. And once we're done with the list, we're done with all of that. The next thing is to figure out our safety squares for each turn. In retrospect, it might have been better to actually just save like the map for each turn, but I was trying to do it as a giant list for everything. I wound up changing it to a hash map of lists for reasons I will get into in a minute. And then basically from there, we're going to move the blizzards. We're going to increment our turn so we know which turn we're on. And then we're going to go through everything in the board. And remember, this is 1 to max Y inclusive and max X inclusive. Otherwise, you're going to be off by 1 because you include rocks or anything like that. And then basically, if there's a blizzard in that location, we're going to skip it. If there's no blizzard in that location, we're going to add this to our list of safety squares for the turn. And then in the hash map for that turn, we're going to save that whole list. And again, I'll get into specifics on why I chose it that way here in a second. All right, the last part is the pathfinding. I originally written this as a recursive algorithm, which worked fine. It was just a little bit slow. I wrote it as a breadth first instead afterwards, which worked better, but not great. I will get into some of the things I did to make it a little bit faster in a second. But mainly, so I put it into a priority queue instead of a regular queue so we can change the order. And then add our starting values, so our current X, our current Y, and our turn. And then basically, as we do in any standard breadth first search, pop the first item from the queue. And then this is just if there happen to be 2 different ways to get to the same coordinate at the same turn. Remove the rest of them. We don't care about transpositions. And then if we're at the goal position, then go ahead and return. And then the next part is to go through the safety squares. So if we don't have safety squares for this turn yet, go ahead and keep incrementing the turn and adding safety squares until we get there. And then we check all of our directions. So if we can move right, we're going to add a item to the queue for the right, and then down, left, up, and wait. And wait, you also need to add one for the first value, because I don't have any way of adding something to the safety square for that. I mean, I could just add that in every version of the list, but it's easier just to say, if you happen to be there, you can always wait. And then once that all runs through, we just return whenever we hit here, or min value if there's no path. So on the speed up functions, basically two things that I tried here. First was to do a priority queue based off of turns, and then break ties based off of how far away you were from the end. So the closer you were, the faster we wanted it. That sped up things up a bit. Then I tried to do it where it was actually just strictly the number of turns that we've taken plus how far away we are from the end. For each, these got changed to absolute value for part 2, which we'll get into in a second. And then the problem was, even though this would add fewer things in the queue, the safety squares weren't getting cleared out fast enough. So down here, oh yeah, so I had deleted that. But I had an option in there that if we were past the last turn for a safety square, we could delete them out of the list to keep the list clean. But that was, it wasn't keeping the list clean enough, basically, to do this way. So we'd have some items that would just run through that should be closer. And again, the actual priority queue itself was shorter, but the number of things that we're checking on kept just growing and growing. And it was a lot slower that way because it takes a long time to check through a list of 1,000 items. Or, you know, actually I think it got to like 60 or 70,000 before I killed it. So then the next thing I tried doing, which actually sped up things quite a bit, it moved part 1 from like, I don't know, maybe I think it was like 350 seconds down to about 7 or 8. Was to, instead of doing the safety squares as a single list, that's what I did as a hash map. So every turn just has its own list. This obviously stores way more memory, but we only have to ever search for a small number of items. You know, like I think most turns only have like 20 items in them at most. So it's pretty quick to go through in that case. And then basically I was able to use the same priority queue at that point. So the comparator just being, again, your total number of turns you've taken, how many turns it would take to get to the X position, how many turns it would take to get to the Y position, minus the same for the second item. And so basically, if you could just walk there directly, how long would it take? And that's, of course, the one we want to check first. So to use all of that, in part 1, basically it's pretty simple. We just do the breadth first search and spit it out. So in part 2, the way things got more difficult was to basically have you walk all the way through the map and then turn around and walk back and then walk back again. So you had to iterate 3 times. And the difference being that the storms and everything kept the same positions that they were at. So it didn't like restart. It was whenever you finished, it's, you know, the first one's like, I don't remember, like 250 something minutes. Then you started at minute 251 and you work your way back up and then so forth. So all you have to do for that is basically just take them in for each of them, and then basically start each one at a turn of min plus, or the next turn basically. Actually, I don't need that. That was a test. So all said and done, it takes about 7 seconds for the first one, and I remember it was like 25 or something for the second one. Yeah, so about 8 seconds for the first one, about 27.5 seconds for the second part. Again, I could probably do some stuff to make that a little bit faster, but it's going to take way more time than it's worth at this point, because it's already running fast enough to use. So anyway, that's it for day 24. We have 1 day remaining. As always, if you have any questions about any of this stuff, you can hit me up in the comments. And of course, you can check the newest code and the GitHub links down below. Other than that, I will see you guys tomorrow.